So we usually are very punctual. We start at 6:30. So, Charles, the floor is yours. I'll make you also a co-host.
Okay.
Introduce yourself and the subject for today.
Okay. So, well, hello, everybody. I don't know how many people we've got. I'm Charles Williams. I've been an Excel MVP for the last, I don't know, 15 years or something. I haven't been working with Excel as long as Israel, as we just discussed. But my specialities are VBA and Excel performance has really been my thing for many years. I don't quite know why. I just sort of got sucked into it, probably from that initial job I had trying to build this satellite model when, you know, it really was important to try and make the best of things. So let me try sharing my screen. How's that look? Okay. Anyway, so that's my location. That's my email address there. So feel free to reach out to me on email if you want to discuss anything that comes up during this session. I have a website, decisionmodels.com. It's got a lot of information about Excel calculation and also hosts my Fast Excel product. And there's a blog, fastexcelwordpress.com, which has lots of miscellaneous blog posts about anything that interests me, really, mostly to do with Excel. Sometimes I divert into wine tasting and other things, but, you know, hey, mostly it's about Excel and VBA and all that kind of stuff. So what we're going to talk about today is finding Excel calculation bottlenecks and speeding them up. So we're going to start by using my Fast Excel profiler thing to try and show how to find the calculation bottlenecks in a workbook. If you already know where they are, of course, you don't need that step. Then we're going to work through a lot of examples of speeding up formulas. The great thing about Excel is there's always millions of different ways of doing the same thing. And some of those are much faster than others. So it's important to be able to try things out and see what works well and what doesn't. Then when we've run through all that, we'll try and summarize with my 4 golden rules for speeding up Excel. And then depending how the time's going, we'll get into using my free Lambda Explorer add-in for understanding and debugging Excel formulas. Because Excel's not really very good at that, doing that these days. The tools that you have for evaluating formulas and looking at them are ancient, to say the least, and really past there. That's why I wrote this free add-in to try and make it work better. So the thing about Excel is it actually calculates really fast. I've got a workbook on this laptop, which has got 5 million formulas, and each formula does 4 operations. It adds 4 cell references together. So that's a total of 20 million operations. And how long do you think it takes to calculate? Well, it's fast. It takes about 1 second to calculate on this laptop. So given that Excel calculates so fast, why do we have slow workbooks? That's the question. And in any slow workbook, most of your formulas will be running fast. It's usually, you know, just a few of them that are slow. And so the trick, first of all, is to find out where they are, the slow ones, and then try to work out how to speed them up. So I built this tool, Fast Excel Profiler. You don't have to use this, but it's a very convenient way of finding out where the slow bits are in a workbook. So what happens is you profile the workbook, and it shows you what the slowest worksheets are and sorts them out in priority order. And then you can drill down into the slowest worksheets and find out what the slowest formulas are on a worksheet. Then you can focus on speeding up the bits that are slow. There's no point in trying to speed up things that are fast, you know. We don't need to do that. We'll only introduce errors. Now, one important thing is to talk about with Excel is multi-threaded calculation. Now, what Excel tries to do when you ask it to calculate a workbook is to spread the calculations across all the cores on your PC and calculate things in parallel. Because, and this is probably the biggest speed-up introduction that Excel's ever had. Because today's PCs, of course, have got an increasing number of cores. The only problem is that there's an overhead in Excel working out how to spread things across cores. So sometimes it gets slower. I had a case a couple of months ago where a guy had a machine with 96 different cores on it, and it was calculating slowly. And it turned out that if you switched off multi-threaded calculation and told it to only calculate with one core, it ran a lot faster because the overhead was killing things. Now, that's unusual. Most of the time, you know, Excel makes good use of multi-threaded calculation. But there are some things that are inherently single-threaded. And if you've got a lot of these in your workbook, they will make it run slow. These are things like indirect, which I call Excel's most evil function. Get pivot data, cube functions. If you're running the circular references, iterative circular references, that's single-threaded. Iterative data tables, often used in real estate calcs and so on. And VBA and automation is pretty much single-threaded. So, oops. Now I'm going to switch back to Excel, if I can work out how to change to this one. This is a workbook profile produced by Fast Excel on a large and complicated.
We still see the presentation.
Still. And why is that?
You have to make a new share screen.
Yeah, okay. Try that. That better?
No? Okay, now we see the Excel.
Okay, good. Thanks. So this was a budget workbook, pretty large and, well, not that big. It's about 11 megabytes. It's got 40 odd worksheets, but it takes a minute and a half or 2 minutes to calculate every time, which is pretty bad news. And so they came talking to me saying, how can we speed this up? So I started by running the profile thing on it, and it showed that most of the time was being spent on these 3 or 4 half dozen worksheets. So we look at this, we can see that there's a worksheet called NE, and it's taking 53 seconds to recalculate. And it takes 54 seconds odd if you tell it to calculate all the formulas on the worksheet, as opposed to doing a smart recalc of only the minimum set of formulas.
How do you measure recalc period?
Sorry?
How do you measure the time for recalc a spreadsheet?
I use VBA, and I use the high resolution Windows timer.
Okay.
And basically it's using VBA calculation methods and timing them. So we do a worksheet calculate, and then a worksheet full calculate to get the 2 times, compare the two, and if the two are nearly equal, yeah, we've got a lot of volatility in that worksheet. So we can see that, yeah, there's a lot of volatility there. There are a total of 40 worksheets in there, but I didn't bother to show all this because most of the other ones run pretty fast. So we don't need to look at that. So the next thing to do is to look at the formulas on that worksheet. And it turns out that one particular formula, although there are 3,200 of this particular formula, takes 48% of the time. And over there, it's flagged as being B. It means it's a native Excel function. It's a volatile formula because it's got some volatile functions in it. And it's single-threaded. So it's pretty bad news all around. The formula itself is pretty horrendous. Oops. No. Let's go back to...
See, it has the filter function, so it's a quite new worksheet.
Sorry?
I see the filter function, so it's quite new.
Yeah. Yeah. Let's see. It's not behaving. Yeah, so it's a pretty horrible formula, as you can see. If we can look at it with my free Lambda Explorer tool, and that will give us a better view of the formula, which will show it to us in indented form with any luck. It's not behaving.
You're in edit mode. You have to hit enter and then click.
Okay. Thank you. Why do demonstrations always go wrong? So it's a nice way of looking at a formula. We'll look more at Lambda Explorer later on, but I just wanted to show you that. So, okay, what can we do about this is the question. What I actually did was to make some changes. They were using indirect a lot. And the reason they were using indirect was because they wanted to protect the formulas against when they inserted extra rows or deleted extra rows or whatever. So they were using indirect just simply to refer to the row above whatever the row the formula was in. So we could replace that with an index statement, index a particular column using the row -1. So put that in all the 3 columns, and then we used a let. It was quite a lot of repeated calculation of a particular column, and so that the calculation was done several times within a formula. So using the new let function, we could extract that once, put it in a let variable, and then reuse that variable. And that's a lot more efficient than doing the repeated calculations. So those are the kind of changes that were made. And so let's get rid of that. Yep. So that was before and afterwards. So we got the calculation time down to about 3 seconds, recalculation time down to about 3 seconds from 1.5 minutes. And most of the slow sheets, we got down to something very reasonable. We were left with 3 sheets that we didn't tackle. We ran out of time. It was just too complicated. We probably could have done something about that as well. But that left those 3 sheets as being the critical ones. So that's a sort of real-world example of what can be done to speed up slow workbooks. Bit of an extreme case, but not the only one I've met. Now let's look at an example workbook that shows lots of different ways of doing the same thing and comparing them to see how the calculation goes. So we'll switch to this one. Okay, so this is my demonstration workbook. It's got several worksheets. You can see that the sum ifs worksheet is the one that's taking most of the time. There's very little volatility in there. The recalculation time is very fast. The full calculation time is pretty slow. And it's reasonably efficient for multi-threading. So let's actually look at the first worksheet, which is the sum ifs worksheet. So what we're doing is...
We still see the before and after.
Sorry?
We still see the before and after spreadsheet.
Oh, I got to reshare every time, right?
Yes. I usually also recommend not make functions on the whole column. Even if you don't know what is the size, decide 100,000 rows or something like this, but do not write functions that calculates all 1 million rows.
Well, it depends. Some of them are happy to do that. Sum ifs is one of the functions that doesn't care if you give it a full column reference. Other functions do care. So what we're doing here is a sum ifs over 10,300 rows using 5 filter conditions. So if we use this sum ifs formula, I don't know, can you see that okay? Or do I need to magnify it? Let's just go. Okay, so we're using full column references. And this set of formulas takes about 17 milliseconds to calculate. So it's pretty fast, even though it's referencing a full column. Interestingly, of course, the way sum ifs actually works is it evaluates the first criteria and then passes the rows that match the first criteria along to the second criteria and so on. So it's filtering down as it goes progressively through the criteria. So it turns out that if you put the most restrictive criteria first, sum ifs runs faster. So that's what I did here. I changed it so that the sequence of calculations, sequence of the criteria was the first one was on column A, which has less results. And that takes around 5 milliseconds as compared to 17 milliseconds. Now, okay, 17 milliseconds is fast enough anyway, so who cares? But sometimes with sum ifs, you're going to meet cases where it's a lot slower, and this trick can be a lot better. If we look at that with Lambda Explorer, you can see the different criteria. And if I pick this one up in the top right, we can see that the result of that criteria expression is column A equals M7. It's only got 500 rows in it compared to the 10,300. So putting that one first gives us a much smaller number of rows that we're passing along to the second criteria, which, since it's a greater than or equal to, it's getting it filters out a much larger number of rows. If we compare that to doing it with a sum product on a full column, that is a disaster, because sum product functions like an array formula, so it has to calculate full million rows. So it's calculating sets of virtual columns of a million rows each and multiplying them together. So this set of formulas takes 3,000 milliseconds, 3 seconds, a lot slower. Of course, if we make it use ranges instead, there's not a lot of difference with the sum ifs. It still takes 5 seconds for the resequenced version, but the sum product, when we're only referring to the 10,300 rows as opposed to the million, yeah, comes down to rather more reasonable time of 53 milliseconds. It's still a lot slower than sum ifs because it's not doing this progressive filtering that sum ifs does. If we use the more modern filter function to do the same thing as the sum product, it's pretty much the same time. You know, I don't think you could really tell the difference between them. If we just time that formula, and we're running slower today. It's taking 86 milliseconds as compared to 48 milliseconds. Probably because we're on Zoom and we've got a lot of things happening in the background and so on. So, you know, doing timing comparisons can be tricky because Windows is a nice multitasking operating system. So lots of things are going on in the background, and it's no two timings are ever exactly comparable.
We may say something about this. I'm teaching the students do not use sum ifs anymore. Use just sum and filter. But you show that sum ifs is faster than sum and filter.
Absolutely. Yeah.
Okay. I have to change my slides.
Well, the thing is, I mean, for these kinds of examples, unless you're using sum product on the full column, it doesn't matter. I mean, they're all fast. Okay. So it's only when you find a situation where things are slow that you need to do something about it. Otherwise, yeah, it doesn't really matter. If something's taking, 100 milliseconds as opposed to 50 milliseconds, you're never going to notice. There's no point in doing anything about it. Yeah, but filter is essentially it works the same way as sum product. It's got to work with virtual columns, doesn't do the progressive filtering that sum ifs does. And that's true for its sum ifs, count ifs, and all the other kinds of ifs formulas. Any questions on
the new function works slower than an old function?
Yes, but I mean, you can do sum ifs has limitations. It'll only work with ranges. It won't work with arrays. Some more complicated comparisons, some criteria calculations get very difficult to do with sum ifs, but are simpler to do with filter. So, it depends what it is you're trying to do, what the problem is you're trying to solve. Any more questions on the sum ifs and filter and sum product and so on? Okay, let's move to the next one. So this is a little example of counting uniques, ignoring blanks over 10,300 rows. So we start with an array formula using if. So if the length of the cell is greater than 0, we do the calculation. Otherwise, it's a 0. So that is pretty slow. It takes 1,335 milliseconds, 1.3 seconds to do that over the 10,300 rows. And sum product takes almost exactly the same length of time, not surprisingly, because it's basically an array formula under the covers. VBA UDF, I wrote, is a lot faster, only takes 19 milliseconds. An XLL UDF, which is written in C++, is about twice as fast as the VBA UDF. And it's multi-threaded, whereas the VBA UDF would be single-threaded. So we'd get a lot of benefit out of that. But of course, if we split the thing down and start using helper column, so here I've got a simple little formula which says, let's look at the previous row and see if it's the same as this row. And if it's the same, we get a 0. And if it's different, we get a 1. So this helper column only takes a couple of milliseconds to calculate. And then I can...
sorted.
Yeah, it has to be sorted. Absolutely. Yes. And then if I add up if I do a sum of the filter column, that's very fast as well. So the other thing to think about here is that what we've done is we've broken the formula down into a lot of different formulas, and we used a helper column. And that exploits Excel's smart recalculation method. And it also exploits the multi-threading, because we spread things out into lots of different formulas. They can be calculated in parallel across the cores. And for smart recalculation, obviously, if we only change one of these cells, then only that one formula will recalculate rather than all the 10,300 formulas. And the sum will recalculate. So in a lot of circumstances, splitting things up into helper columns and so on really makes life a lot faster, helps Excel to calculate faster because we're exploiting its multi-threading and smart recal. However, there's an even better way of doing it, which is with this dynamic array formula using the new unique function. That only takes 0.7 of a millisecond. So that's a series of different examples where one way of doing it takes 1.3 seconds, and the fastest way I found of doing it takes 0.7 of a millisecond. Lots of different ways of doing the same thing. Questions on that?
No.
Oh, good. Okay. Next example is a period to date calculation. So we've got some dates and some values, and we want to just calculate what the sum of all the values to date is. So as we go down, each of these formulas is calculating, looking at more and more rows. That's a simple enough formula. We anchor the beginning cell and use a relative row reference for the second cell and put it in a sum and copy down the formulas. So it's not too slow, but it's taking 150 odd milliseconds to calculate. And if we think about it, on average, each of these formulas is doing a sum over 5,000 rows. First one's only doing a sum over a few rows, but as you get further and further down, it's calculating over more and more and more rows. And it's repeating things. So a cleverer way of doing it is this. We just add the previous summed value to this value. So that's only doing 20,000 calculations compared to the other one was doing 5 million, 50 million calculations. So you'd expect it to be a lot faster. It is a lot faster. It only takes 8.5 milliseconds to calculate. Now, unfortunately, it's not 50 million times faster because there's overhead, obviously, in terms of fetching the data, interpreting the formulas, and calculating them. But it's an example where if we can find a way of doing the same calculation, but referencing fewer cells and doing fewer operations, Excel will calculate things a lot faster. Now, Another way of doing the same thing is I wrote an accumulate function, and that does the whole calculation in 2 milliseconds. So that's a lot faster. Equally, we can use some of the newer Excel stuff. So that's a scan function using a lambda to accumulate the functions. I don't like scan personally. I find it kind of hard to understand, but it can be useful in these circumstances.
Remind us what the scan does.
Scan, it's processing things value by value, and basically it's applying this lambda function, which is, if you look at it, it's adding the two values together. So we've got an accumulator value and a value, and it's adding them together. So it's scanning down the row of values, and basically, in this case, doing the accumulation. But you can obviously do a more generalized kind of calculation using scan. This is a fairly simple one. But again, it's a lot faster than even doing the simple calculation this way, and certainly a lot faster than doing the period to date calculation in the most natural way of doing it, which is with an anchor cell and copying down. So
excuse, I have a question, please.
Yep.
The accumulate table, you wrote this function on VBA?
Accumulate.
Yes.
No, that one happens to be a C++ function.
I see. Okay.
But you could write it in VBA. It would probably only be 2 or 3 times slower.
Okay. I would only like to add to my colleagues that the scan function is one of the few dynamic array functions that makes you loop through all the numbers of array. It behaves like you are doing loop in VBA.
Yeah, that's a good explanation. Thank you. Okay. Next is another example. We want to count all the rows where the numbers, each of the numbers is greater than 100. So here we've got that's greater than 100, that's greater than 100, and that's greater than 100. Yeah, so we want to count that row. So we're going to do it different ways. We're going to do it with an array formula, with a sum product, with countifs, and with a helper column. So this is the array formula. Sum A 10 to greater than 100, B greater than 100, C greater than 100. Answer is 266. We've got 500 formulas over summing over 200 rows, and it takes 180 milliseconds. So it's quite fast. But if we had a lot more data, it would start getting very slow. Doing the same kind of thing with sum product, yeah, it takes virtually the same time because sum product is basically an array formula. Doing it with countifs, yeah, same kind of thing as we had earlier on when we were looking at SUMIFs. It's faster than sum product or array formula calculations. But we can make it a lot faster if, again, we split the thing up into a helper column and a sum column. So the helper column just says if cell A is greater than 100 and cell B is greater than 100 and cell C is greater than 100, it's a 1, otherwise it's a 0. And so calculating all that set of columns takes, using this calc range function, takes a couple of milliseconds. So it's fast. And then we can sum the column, the entire column, and that takes around 7 milliseconds. So again, splitting up this calculation into separate formulas, although we've used a lot more formulas to do it, the overall result is a lot faster. Because again, it's exploiting Excel's multi-threaded calculation, and we're exploiting also, if we make a change, the recalculation will be a lot faster because we won't have to recalculate all the formulas. Any questions about that? Okay.
Usually I teach students to make helper columns, just not to make mistakes, but now I see that it's not only not make mistakes, it works faster.
Yes,
Yeah.
it's fascinating. It's simply fascinating. Thank you very much.
The other nice thing I think about splitting things up into, I hate mega formulas, because mega formulas tend to be slow, and also they're complicated, they're hard to understand, and you tend to have mistakes in them. So the more you can split things up into, split mega formulas apart into multiple formulas, less likely you are to have mistakes, and the faster Excel is going to run. There's a slight counter to that, of course, because with modern Excel and dynamic arrays and all these fancy new functions, you tend to find yourself building large formulas. So, it swings and roundabouts. Some things are good and some things are bad about these these new dynamic array formulas, in my view. But I like them. Okay, next one is the classic lookups. Okay, so we're going to be looking up, we're doing 5,000 lookups over 20,000 rows. Not that big a chunk of data, but some of the values that we're trying to look up don't exist. So if we do it with a standard VLOOKUP, using unsorted data, exact match lookup, we'll get a #NA. And standard VLOOKUP, even today, although they speeded it up a lot with the speedy lookups function in the later versions of Excel, because they're building dynamic indexes under the covers and using those, it takes 497 milliseconds. The data is actually sorted, and if we use I can build in an error handler with an if error statement to get rid of the #NA if I want to. If I use the approximate match version of VLOOKUP on the sorted data, that's using a binary search algorithm, which is much, 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 much faster than the standard VLOOKUP, which is basically doing a linear search. It starts at the top of the data it's looking at, goes down until it finds the answer it's looking for. If it doesn't find the answer, then it's going to continue searching through to the end. Whereas the binary search on sorted data is very, very fast. It only takes 2.5 milliseconds compared to the 500 milliseconds for the exact match lookup. But of course, the problem is it's an approximate match. So it gives us the wrong answer on missing data, like for these two values here. Now, there's a way around that, which is to do the double lookup trick. So we start by doing a lookup of itself. So we look up B5 in A5 to A2002. And if the answer of that, but we use an approximate match, which is fast. But if the answer from that isn't the B5 that we're looking for, the answer the thing we're trying to find doesn't exist. So we'll give it a we'll put a blank out instead. If it does exist, then we'll do the true lookup. In this example, okay, it's returning itself, but usually you'd be with a VLOOKUP, you look up one column and you return a result from another column. So that way we can do, if we've got sorted data, we can make our lookups much, 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 much faster. And sorting stuff with Excel is very fast. So this is often a good solution to speeding up your lookups. Now, of course, there's this new XLOOKUP function, which I tried. And usually I find when comparing XLOOKUP with VLOOKUP that they're about the same speed. XLOOKUP tends to be slightly slower. In this case, I don't know why, it's nearly twice as slow. And it may be I'm using the beta version of Excel 365, so they tend to be running lots of tests.
But you have an option to add a parameter that says it's sorted.
Yeah.
So I think if you add the tell Excel it's sorted, then it won't be in 957 milliseconds.
Okay. Let's
after
try that.
After the end.
So it's
after the quotation marks, comma.
Hang on, let's get that. And
another comma.
Oh yeah, I forgot about that.
And now binary search.
Wait a minute, why is that not working? It's not giving me the right answer. It is fast. I think I've got something funny in the data. Which is okay. I don't know why I'm getting the wrong answer there. You can see here it's...
The blank cells are confusing him.
Yeah. Oh, what's happening there? Any ideas?
Maybe we have to say also in the parameter that you want unknown, not exact match in the function.
Just check that I have actually got nothing funny in this data.
You didn't tell Excel that it's not exact match. It's an exact match in the XLOOKUP. After the first comma, after the quotation marks. Match mode, yes. I think it should be 1. Or -1 if we want to use like VLOOKUP. The smallest one that's still near. So the right -1 instead. Okay.
Nope, doesn't look right. I don't know what's happening there.
Right. No, something's wrong.
Yeah.
By the time it takes,
it was fast when we did the, yeah,
0.1.
6 milliseconds. So yeah, it's fast. It should be fast. But we need to work out why it's not giving us the right answer. I don't know.
Maybe we need to
Guys, it's the
debug it for
demo
Microsoft.
effect. You know, this is exactly the demo effect.
No, maybe Microsoft have a bug that we have to report.
I don't think there's a bug. I think I mean, maybe there is. I could certainly report it, but I don't know why that's doing what it's doing.
Maybe the numbers appear only as integer and it's 1002.9. It's not the integer numbers. I'm in column B.
Looks okay.
Yeah.
I mean, you know, everything else has worked okay.
As I'm looking row 10, when you have the mistake, row 10. Yes. Interesting.
I can't see what's wrong. Can you?
Can you delete the formula that you have in column A and just use the sequence, for instance, to make this column? Sequence to 20,000. It will be spelling.
Uh,
20,000. No, that's it. No need for all the rest.
yeah, okay.
It's still not empty. Let's do 10,000 instead of maybe you have to run to 20,000.
Uh-huh. I think we had some blanks in there.
Change it to instead of 20,000, 1,000 to 10,000.
There were some blanks in there. That was what the problem was.
Now it works okay.
Yep.
The numbers, although they appeared the integer, they weren't.
Yeah. Yeah, there were some blanks in there, which meant that it wasn't actually sorted. So that was what the problem was. Okay. So XLOOKUP doesn't have a bug in. It's my data has a bug in. Thank you for sorting. Okay. So yeah, I'm still left with the puzzle of when I'm doing XLOOKUP on exact match unsorted data, it's slower than VLOOKUP. I don't know why. It shouldn't be. Otherwise, in general, XLOOKUP is a much better function than VLOOKUP.
Definitely.
Yeah. Okay. So we've gone through all the examples. Let's go back to.
I told the next spreadsheet tax, you're going to show us how to pay less tax.
Sorry?
I see the next sheet is tax.
Oh.
So I hope you can teach us how to pay less tax using Excel.
Unfortunately, I don't know. Okay, now we've gone through quite a lot of different examples. Let's look at what my golden rules are. And I got to reshare the new share. Go back to that. So 4 golden rules, which we've had sort of examples of most of this as we've gone through the different examples. Rule number 1. Okay, rule 0 actually is find out what the slow formulas are and only work on those. Okay. So rule 1, get rid of duplicated unnecessary calculations. When you're looking at a slow formula, it helps to try and work out what you're asking Excel to do. How many cells are you asking Excel, this formula, to look at? How many operations on those cells are you asking the Excel function or the Excel formula to do? Because obviously the more you're asking it to do, the longer it's going to take, because basically it's calculating pretty fast. So find a way of reducing things with the repeated calculations to helper cells. This is the sort of classic index match kind of thing. If you want to do a lot of lookups, you can build a helper column using match and then have multiple index statements that refer to the match that you've done, rather than doing the lookups lots of times. When you've got something within a formula that's repeated, you can use let to do it once and then use the let variable in the place of the repeated calculations. But of course, you can't do that between if the calculations are not within the same formula. And splitting things up is good. If all things get desperate, yeah, you can use copy-paste values on your formulas to convert formulas that aren't going to change into values so they don't have to recalculate. It's a good idea generally to try and, in that case, you want to keep the text copy of the formulas somewhere so you can make it, turn it back into real formulas if you want to. And try and minimize the scope of the calculation. And one way of doing that is with if. If is sheer magic as a function, because it short circuits. What that means is, in the if statement, if this is true, do this, otherwise do that. It's only going to do one of those conditions. So you can put a switch in if you've got an expensive formula that you don't always want to calculate, you can say, if this switch is true, do this formula. If it isn't true, don't do the formula, return something else. So you can short circuit things. It's a good method of parameterizing your workbook to only calculate the bits that you want to. Yeah, XLOOKUP, it's good. VBA, UDFs, and so on can be efficient, but they can also be very slow, so you've got to be careful with those. Minimizing the number of cells. Be careful with the full column references. They're fine in some things like SUMIF, but not so good in other functions. And if you've got sum product and array formulas, be careful about them. Consider replacing them. Smart recalc is really important because it's one of the key Excel methods for speeding up your workbook calculations. So nasty things that are volatile functions like indirect and offset and so on mess up the smart recalc. They force all volatile formulas to be recalculated. Offset, on the other hand, is actually a very fast function. And so sometimes it's a good method to use rather than trying to do some more complicated thing. Exploiting multi-threaded recalc is important because these days almost everybody's PC has got 4, 8, 10, 12, 20 different cores, and so you want to really make sure that you're using those properly, and that essentially boils down to trying to avoid those single-threaded functions like indirect. Minimizing the sizes of ranges and breaking things into helper columns and rows. So we've seen examples of all these things, and in the real world example I showed, we can see how it's possible to speed up workbooks by large amounts. Hey, there's no point in trying to speed up a workbook by 10%, okay? I mean, you're never going to notice. You're looking for orders of magnitude speed up if you've got a slow workbook.
I would suggest to add to rule number 2. Yes. Don't use conditional formatting too much.
Conditional formatting?
Yes.
Yeah.
It also takes a lot of power.
Yeah, I didn't really cover that. I was going to. Excel, one of the slowest parts of Excel is updating the screen that you can see. So you get into the ridiculous situation sometimes, well, in theory, whereas if you have a lot of very large screens that you're using to display all your workbooks, Excel will run slower than if you're running with a small screen that's not showing you so much at a time. And conditional formatting is part of this rendering process. Now, that rendering process, the screen updating, only happens on the bit of the screen that you can see. It doesn't bother doing that. So if you have a lot of conditional formatting on sheet 2, and you're looking at sheet 1, that conditional formatting on sheet 2 is not going to be used.
So in other words, you say that if I see the resolution, the zoom of the window, if it's 100 or 200, if it's 200, it will work faster because we see less data.
In theory, yes. Whether you'll notice it or not, I don't know. But I mean, it depends. But that's one of the reasons why conditional formatting is slow, because it happens in the rendering layer.
You see this more often with
VBA when it gets really important to switch off the screen updating. But you're right.
Application screen updating equals false.
Yeah. Final golden rule, and possibly the most important one, is when you're trying to speed things up, you need to time the formula, make the change, time it again, because maybe you didn't make it faster, maybe you made it slower. And critically, let's avoid the bug. Let's make sure it gives the same answer. I've got caught by that a number of times. You think you've made some really clever thing to speed things up, and whoops, it's wrong. Okay, so that's enough about speeding things up. How much time are we doing for time?
We have another half an hour.
Okay. Right. So let's go back to my Excel workbook. Let's share the screen again. And we're not going to look at the tax data worksheet, actually. But we're going to look at Lambda Explorer. This is my tool. It's a free add-in written in VBA, and it's designed to try and help you understand and debug formulas. So this is an if statement. It's a simple one. And we can see that Lambda Explorer has shown you the formula in a nice indented form, and it's split it out into different expressions. And the green bits were tracing the path of the if through. So these are the true bits in the if statement. Now, for this example, this is trivial. You know, it's a very simple thing. But when we've got a very complex set of if statements with lots of parentheses, foresting all over the place, this technique makes it a lot easier to see what's happening. We looked at it earlier on in terms of a sum if, but let's look at that again. And let's refresh that. So this is another sum if. We've got an offset in there. We've got a couple of Excel tables we're using. It's flagging the offset as being volatile. It's in yellow. We've got this purple thing here. I don't know whether you can see that. When you hover over it, we get a little tooltip showing up saying that's a named formula. So when I click it, Lambda Explorer expands it to show you what the named formula is. And it's just doing a match on the worksheet. Click it again, it contracts it again. So we've got all the different expressions in there. Again, we've got, and we're filtering things out here. Here we can see the results of what that of what that criteria expression is. We can run it in debug mode. So as I go using the arrow keys, we will gradually convert functions to values. We can trace through what's happening, and we can look back at the things that have been converted to values and see what the result of that is, and see what the table actually was. We can go forwards and backwards. These are all differences to the way these works a little like the standard Excel evaluate formula debug tool is, except that it handles large amounts of data much better because we can filter things out. We've got a lot of data. We can decide to look at only the things that are errors, false, true, and so on. And we can make small changes to the data. It's not a full-blown editing tool. It's really designed to, you know, if we've got a bug in there, we want to see what happens if we make a small change, then we can make a small change to the formula and see what happens.
Where can we download this tool?
Off my website. It's the website, you know, the
what we saw on the first slide.
Yeah.
Okay.
On the first, gave you the address. Yeah.
Also, people asking me in the chat if it's possible to get this file, the demo.
To get
this file you're showing us.
Yeah, sure. Yeah, I'll send it to you.
Okay, thank you.
Right. So that's that some ifs. So let's look at some lambdas. This is a fancy lambda function written by a guy called Sergey, who's much cleverer than I am. And when he writes these clever lambda functions, I have trouble understanding what it is they're doing. What this function is actually doing is it's looking at this data up here, and it's trying to find out, count how many rows have got the same numbers in them, even if they're in a different sequence. And just inspecting it, it's kind of hard to see because the the numbers are all in different sequence. So let's look at it with Lambda Explorer and see what happens. We've got a purple thing which says we've got a named lambda there. If I click on it, it will expand. And we can step through it and find out what this lambda is actually doing. So we're passing in a value which is the range, and we can see there are the values for the range, and that's actually that data there. So it's a named range containing those values. And that's passed into the lambda as the array. And then we've got a let. And the let is defining RWS as a let variable, which is the number of rows in the array. So the number of rows in the array is 6, surprisingly enough. You can see the actual array is a 6 by 6 array. And then we define another column, another let variable called
another 6,
which is also 6. Okay, and it's the columns of the array. And we've got color coding here. The RWS is in pale blue. That's a lambda variable. Sorry, that's a let variable. And the green is the lambda parameter, just to make it easy, because these things get complicated. It gets easy to get confused about what's what. Then we have a sort rows is actually another lambda function. I'm not going to expand it because it's, we haven't got time to go through all that. That one is actually quite complicated. Basically what it's doing is it's sorting the data in each row. So we can see the results of it up here. So it goes 3, 4, 5, 8, 17, 21. That's the data sorted 5, 8, 3, 17, 21. So the data is now, each of the rows is now sorted. And that's then passed to a unique function. And the unique function only returns 4 rows because some of the rows are the same. So 3, 4, 5, 8, 17, 21, that top row is the same as this row here. And must be another one somewhere. Can't see which one it is offhand. So the sorted rows are passed to unique. So that only gives me the 4 rows. And then, so that's distinct. Put in the distinct variable, let variable. And then the final calculation in the let says, okay, the original rows, which was the number of rows in the input array, minus the rows in the distinct array gives 2. So that's the answer for this function. So it's the number of rows that contain the same numbers. Now, looking at the lambda, without doing this, it gets quite hard to understand what it's doing. It's a fairly simple example, but this is a good method of seeing what the lambda is doing and trying to work out where it's going wrong and understanding it. Let's look at another one. This is a recursion example. Recursion is quite hard to debug, I think. So in Lambda Explorer, when we click the function, it expands and we can see that stack depth appears again. So it's calling itself as in recursive method. What this is trying to do is it was a test that was written by the guys in Microsoft Research, test Lambda, to see how deep you could go in recursion before Excel fell over. And the answer was about 1,000 recursions. I think they might have increased that originally. So with Lambda Explorer, as you go through each step in the recursion, as you expand each step, it shows you what the variables are for that depth of the recursion. So things start out at 32. In the next iteration of the recursion, they're down to 31. If I click it again, it will expand it again, and we'll be going down to, hang on a minute, let's get this a bit further over here. We're going down to 30 and so on and so on and so on. So when debugging recursive functions, this is the best way I can see of trying to figure out what's going on, because you can't expand the whole thing, because you'd wind up with a formula that's miles long. You'd never be able to work out what's going on. So that's how we handle recursion in Lambda Explorer. That's about. Are we doing on time?
Well, okay. If we are talking about performance, why do you use XLSM and not XLSB?
Why do I use, sorry?
XLSM files instead of XLSB files, the binary files. I find them run faster.
In terms of execution speed, calculation speed, there's no difference. Its XLSB files are faster to open than the XLSM files.
To open and save.
Yeah, exactly, because they're more compressed. I mean, XLSM files are basically text, whereas the XLSB files are binary. Yeah, they're more efficient to open and close. There are some, I mean, if you want to explore the insides of the file, then you'd need to be in XLSX or XLSM file format, because then you can unzip the file and look at what's inside it.
Then it's an XML file.
Yeah. Yeah.
So even updating XML file, because it's a text file and you have actually to update many files, it takes more time.
Yeah. 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 So it depends. I mean, if you've got a big file, yeah, switching to XLSB is good. There are some circumstances like Power Query, for instance, is not very happy with XLSB files. Needs to work with XLSX and XLSM files. So there are some things that are more restrictive with XLSB, but I prefer them on the whole.
In my case, as the default, all files are XLSB, even with no macro.
Yeah. 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 Yeah, because again, you're going to get the advantage of smaller file size, faster opening. It's because the XLSB format is closer to the in-memory format that Excel actually has to use when it's doing its stuff. Okay, let's look at another one. So this is a very simple pair of Lambda functions. So the second function is extracting the second of the pair of little arrays. So the problem is that the second function can't actually be worked out until it's expanded the pair function. So we need to sometimes to get the full interim values out of Lambda Explorer, you need to expand all the functions, because until you've done that, it can't evaluate things. So it gives you this hash expand error message saying we need to expand things to be able to debug them. That's about the end of my stuff to talk about. We'll go back to final thing on the PowerPoint. If anybody wants to buy my Fast Excel product, I've got a nice little 30% discount offer with using that coupon code. It's a fantastic product, of course. And
I'm sure
you can try it. You can try it out. You can try it out for free.
What is the cost after the 30% discount?
Well, it's around about $200 to buy the product, depending on currency and so on and so forth. So 30% off. We'll take it down to
140.
Yeah. It's actually 3 different products in a bundle. So that's you're getting 30% off the bundle. The profiler bit, which was the bit we looked at the results of, is about 1/3 of the price. Then there's a manager bit that has various other things in it. And then you've got the speed tools bit, which is the 100 odd worksheet functions I wrote that run faster than the standard Excel ones. So anyway, there we go.
And it was written in C++?
It's written in C++. Well, the functions are all written in C++. The other stuff is mostly VBA. There's some other stuff in there as well.
Okay.
So we go back to the beginning. That's my website. So the decisionmodels.com website is where you'll find Lambda Explorer and Fast Excel, of course. And there's my email address if you got any questions. So what do you think, guys? That helped you to speed things up?
Thank you very much.
It was very, very interesting. Thank you very much.
Good. Any more questions?
May I ask a question about the C++, if you can replace it with the C#?
You can, well, you can write worksheet functions in C#, but the interface between Excel and .NET is slow. It's actually slower than the interface between VBA and Excel. So it depends what you're doing. C# itself is quite a fast language, but not as fast as C++. But when you're writing worksheet functions, often the critical thing is transferring the data, the range of data or whatever, from Excel into the worksheet function. Then you do your calculations, and then you transfer the results back. And for .NET, that's very slow because it's you've got an extra interrupt layer in terms of on top of the COM interface that VBA uses. So there's lots of good things in .NET, but performance with Excel is not one of them.
Actually, I'm quite disappointed with the 365, many bugs. especially with the screen.
Excel 365.
Yes.
Yeah, they've done a lot of work on that. There was the most recent, there were a lot of problems. It's gradually got better. Current build I'm on is a lot better. I don't see any of those so many of those crazy screen behaviors that you used to see.
You go to a spreadsheet and suddenly the marker goes to column CWX.
Oh.
Out of the blue.
Okay.
And it's a common bug that it doesn't make sense to be common, but it's common.
Yeah. Yeah.
So Charles, thank you very much. It was very enlightening. And now I know that I did well, what I told you in the previous 14 hours. I had a lot of speed tests to find out what is the best value, how many rows to calculate. I told you we have 700,000 rows, and using the macro, I calculate only 250 rows. But to find this number, it took me a week to find what is the correct number that Excel will keep the memory in the same stage and not get stuck. So a lot of speed tests.
Yeah. Yeah. I bet. Yeah. The Fast Excel profiler has also got a VBA profiler. So if you've got a complicated or slow chunk of VBA code, it will do the same kind of thing as the calculation profiler, and will show you, how long each of your subroutines and functions and stuff take to calculate, or you can narrow it down to particular bits of your VBA.
Yeah. So again,
okay.
Thank you.
Look, I promised to send you the files.
Yes, and if you're the presentation also, it can be also good. We were asked in the chat.
Very interesting. Thank you so much.
Thank you very much.
Thank you very much.
Thank you very much. Bye-bye.
Bye.
Bye-bye.
Thank you.
So you send me the files, I'll send all the users. So thanks again, and bye-bye.
Bye-bye. Thank you.